Hello everyone. So in this video we are going to do this question, and this question is based on polynomial equation. You can see the polynomial here and derivatives are also involved. So the question says that let px is a polynomial of degree 100 and the equation px is equal to 0 has 100 real and distinct roots. This is the very crucial information we have. So you have to find out the number of real roots of this equation. Now there are two ways to solve it. First, by using calculus, and in calculus particularly we are going to use the Lagrange's mean value theorem, or just mean value theorem, or Rolle's theorem. And the second one is from theory of polynomial equation. So that also we will see. So if you give a try, that will be more appreciated. So before jump to the solution, you can just solve this question, and if you solve it correctly, you will get the answer 0. Means the number of real roots of this equation will become 0. Therefore, there are no real roots of this equation at all. So the first method I'm going to discuss is by using the calculus. So for that, we have already given that the px has the roots in number, that is 100. So let's say this alpha 1, alpha 2, alpha 3 till alpha 100 are the roots of px. So if px has these many roots, and so suppose these roots are lying over this line like this, and let's say this alpha 1 is here, alpha 2 is here, alpha 3 is here, and up to alpha 100 is here. So if these are the roots, degree of this px is 100, so degree of this px is 100. It means that if this is positive, the leading coefficient is positive, the polynomial equation starts like this and it goes like this, and suddenly will go finally passing through alpha 100 and goes in the same direction, means the positive actually. In the same way, if the leading coefficient is negative, then of course it will go like this and so on. But it doesn't matter what we are analyzing here, that if these roots are real here, alpha 1 to alpha 100, so if I want to try to, if I try to plot the roots of the p dash x, these roots will be the roots of p dash x, and where they will lie? They will lie between alpha 1 and alpha 2. Between alpha 2 and alpha 3. So let's say these roots are beta 1, beta 2, and so on. So this is going to be beta 99, because if px has 100 roots, p dash x will have 99 roots, and the first root of the p dash x will lie between alpha 1 and alpha 2, then the second root will lie between alpha 2 and alpha 3, and so on. So let's try to analyze the sign of this quantity. How do we analyze it? You notice that in this scenario, let me just take it down because I have to also understand. Okay, now I'm going to locate the roots of p double dash x, because there are three things involved here: p dash x, p double dash x, and px. So if the p double dash x exists, and let's say this is somewhere here, and their roots, let's say alpha, beta, gamma 1 here, then gamma 2 will be between beta 2 and beta 3, and so on till gamma 98. Gamma 98. Now, notice what is happening. The idea is very simple. So suppose you draw a graph of I try to draw a graph considering that the coefficient of this x to the power 100 is leading coefficient, that is positive, and in that way the graph may look like this, in this way. But suppose I am taking that the function is going in this way, hitting the first root of it, and at beta 1 it is getting its maximum value because p dash x is going to be 0 at beta 1. So between any two consecutive roots of px, p dash x has at least one root. You know this fact. So here alpha 1 and alpha 2 are the roots. So at beta 1 this will be like this. And this beta 1 and beta 2, in between them, at beta 2 let us say it's the minimum value somewhere, and again it will go up, again it will attain its maximum, again it goes down, and so on. So between beta 1 and beta 2, the gamma 1 is there at this point somewhere. This is the value of gamma. So what is happening at gamma? Because the p double dash x is also 0 at this point, so this point must be a point of inflection. Now notice that two things can happen. The px and p dash x, px dot p double dash x, on the left hand side we have, and is given 99 p dash x whole square. Now notice one thing here, that this value is positive for any function, any x value actually, because p dash x is any function. It can be negative or positive, but you are squaring it, so it will become positive. It means now we have px dot p dash x are obliged to be positive. If these are going to be positive, then what are the conditions? Means what are the conditions we have for the px and p double dash x to make the product positive? So the first situation can happen that the px is positive and p double dash x is also positive. And when this happens, our graph, the px is positive means it lies above the x-axis, and p double dash x is positive means it is concave up. So it is actually very difficult to draw the graph like this, provided we have to also take the roots of this px. Means the all distinct roots we have to take fully, alpha 1 to alpha 100, and in that scenario I have to plot the graph in this way: px greater than 0 and p double dash x is greater than 0. Means the value of x, whatever we have, that should be positive. I mean the px value should be positive, means above the x-axis, and also p double x is positive. P dash is positive means the concave up. But by just inspection we have understood there, by just looking at all this information we have, we found that either the graph will be looking like this, then only all the distinct roots will have. So the p dash x will have their roots and p double dash x will have their roots. So in this scenario, what is happening, that you can notice in this scenario that from here to alpha 1 to alpha 2, let us take any such interval between alpha k and alpha k plus 1. So between alpha k and alpha k plus 1, if px is positive, you can, as you can see here in this scenario, the graph is concave down because it has to take its maximum value, local maximum value at beta 1, it has to come down to take the other roots which are distinct from alpha 1. In that way, in this process, the p double dash x has to be less than 0, because in that scenario the graph will be concave down. But what will happen if I take px is lesser than 0? If lesser than 0, it means in this scenario we have the graph is always below the x-axis, and in that case our graph is concave up. So in this case p double dash x is greater than 0. It means what is happening, that the product is always negative, but what we are demanding is product is positive. The product is positive can be in two cases: the px is negative as well as p double dash is negative. But by this whole information what we have, we tried to draw the graph, and by using this Rolle's theorem what is the theorem we are using here in disguise? That between two roots of any polynomial, the p dash x, the derivative must have one root. If they have alpha 1, alpha 2, there must be beta 1 between alpha 1 and alpha 2, where the f dash x or p dash x will be 0. So in this way, we are concluding that there no root exists for this function. Which function? For this function, because this equality is not holding by this inspection between alpha 1 and alpha 100. But what will happen if I take any root? Suppose maybe this equation is holding for some other values beyond alpha 1 and alpha 100. So let's also analyze that thing. What if roots are, or what you can comment on the roots are beyond alpha 1 and alpha 100? Because between alpha 1 and alpha 100, there is no chance to get the roots, because between alpha 1 and alpha 100, there is no chance that this equality can hold, because you understood this thing. Now what will happen if I have these roots beyond alpha 1 and alpha 100? So we'll understand it. If you can analyze it, that will be better. So I give you time. If you want, then you can pause the video and see how this will be interpreted. So now what if the roots are lying beyond this alpha 1 and alpha 2? So this we have to analyze. So let's say I have this alpha 1 and alpha 100, not alpha 2, alpha 100 I mean to say, and the roots are just beyond that. So let's say the graph is like this, and again it goes like this, because it's 100, so maybe coefficient is positive, so it will go in this way, or it will go in this way. So let's try to analyze this situation. I have the 100 or 99, let me just again check it. 100 px into p double dash x, px into p double dash x is equal to 99 p dash x square. Now let's try to analyze. Suppose I want to approximate this both side. So let's say px I'm approximating with its leading coefficient. Let's say I have a into x to the power 100, the leading coefficient. So p double dash x will have 100a and into 99, because a you have taken out, and then x to the power 99. And on the right hand side, if you go, that must be equal, or yes, there's going to be 99 here, and p dash x square means p dash x is 100 a and into x to the power 99, and then square it. You notice when we are approximating the leading coefficient, they're equal actually. Why they're equal? You can see this is actually turning into 100 was already there, so I have 100 squared, and here a square and x to the power 199. Now really, this is p double dash x, so it should be 98. I did a mistake here, so I have 198. And on the right hand side, if you just simplify this is 99 here, and this 100 square a square, and again x to the power 198. So this a square cancel, and there was all 99 left out, so this 99 was cancelled. So we are getting that if you are taking the leading coefficient both sides, then they are equal. But since p dash x square is actually moving very faster compared to the product of px and p double dash x, this approximation will not work. Means I have taken the first term only. If you take the second term again, and then you have differentiated it one time and then squaring it, so that will be always higher than the left hand side. So I mean to say that if I want to analyze that p dash x square dominates this thing, px into p double dash x by 100 into this and by 99. So by any chance they cannot meet, even if you are taking the consideration the reason or the values beyond the alpha 1 and alpha 100. Now let's go to the next solution what I wanted to present, and that is the polynomial in which we are going to apply the Cauchy-Schwarz inequality, perhaps, because I have done this question long before. So before this video recording I have not tried. Let's try. So what is the idea? Let's say I have the px, and this px I'm taking as, let us say, that is, let's say a100 into x minus x1, x minus x2, x minus x3 till x minus x100. These are their 100 roots. So I can write them in this way also, a100, and then I'm writing this thing pi means the product, I goes from 1 to 100, x minus xi. In this way we concise this polynomial. And now to deal with this situation, let's take the log. So log px is going to be log a100, and this I can turn into the summation, I goes from 1 to 100, x minus xi. Now since I have to involve the derivative here, I can differentiate this both sides. So let's differentiate it. So differentiating this thing with respect to x. So what we get it here, 1 by px into p dash x. And that log 800 is constant, so that will turn into 0. And here each term is in summation. And there is no such problem. It's a linear with the coefficient 1. Therefore, just derivative will become 1 by, by the way, I have taken log there, so I forgot to write. So what we get here, derivative, log x minus x1 plus log x minus x, let me write it, plus x minus x3 and so on up to x minus x100. Now this we can also again differentiate one more time, because here you can identify that the double derivative is involved. So let's differentiate it, and here we are going to apply the quotient rule. So applying the quotient rule, what we get it here is px whole square, and that is going to be px into p double dash x minus p dash x whole square. And here, since the derivative, each derivative is negative 1 by x minus x1 whole square, then x minus x2 whole square, and so on. So I can write this thing as a minus of the summation I goes from 1 to 100, 1 by x minus xi the whole square. I think you agreed on that. Alright, now we have the value of px into p double dash x, isn't it? This is px into p double dash x we have. So we are going to substitute this value out from here in our expression we have. So what we get it here is p dash x square into 99. So let me write it, 99 into p dash x squared divided by 100 and minus p dash x whole square and divided by px whole square, and that is negative summation I goes from 1 to 100, 1 by x minus xi the whole square. Now you notice what will happen here. If we simplify this thing further, that will turn into negative of p dash x whole square divided by 100 into px whole square is equal to minus 1 summation I goes from 1 to 100 1 by x minus xi the whole square. Negative sign will get cancelled, and we have now this p dash x by px and the whole square is equal to 100 times summation I goes from 1 to 100 1 by x minus xi the whole square. Now this quantity you have, this quantity is already we have, I've seen somewhere, you notice that there, here. So this I can also again rearrange and write I goes from 1 to 100 1 by x minus xi, correct? So what I'm going to do is, this quantity I have, this thing, I'm going to write it at the place of p dash x by px. This is summation I goes from 1 to 100, and that is going to be 1 by x minus xi and the whole square is equal to 100 times summation I goes from 1 to 100 1 by x minus xi. I can write like this also, the whole square. So here we have to apply the Cauchy-Squarze inequality. And how do we apply it? Let's see. You know the Cauchy-Squarze inequality, let me write it. The Cauchy-Squarze inequality. And that is going to be the summation. Let's say I'm writing I goes from 1 to, let's say 100 cases here, so I'm taking 100 only, ui vi the whole square is lesser than equal to summation I goes from 1 to 100 ui squared and summation I goes from 1 to 100 vi squared. Now this equality, there's an inequality given there, but there's a strict equality if we need. So if we need equality, I have to have the two series what we are actually considering, the ui and vi. These two must be proportional. ui vi must be some constant k. If there is a equality here. So can we apply this technique or this Cauchy-Squarze inequality over there? But notice in this scenario I don't have two different values, but we can make it. How we can make it? I consider that vi is individually, means vi, each of this vi is 1. So I can think in this way that this is nothing but I have summation I goes from 1 to 100, and that is going to be 1 by x minus xi and into 1 and the whole square. It means each of vi, how many vi's will be there? 100, and each of them are 1. So in that way what I can do is this inequality, and here I get 100 and then summation, by the way, not this one, sorry, this 100 I can write, this 100 I can write as what? This way. Let me write first summation, what I write, 1 by x minus xi the whole square I goes from 1 to 100, and into I need summation I goes from 1 to 100, then 1 square, and 1 square is 1, and you are actually just adding 100 times, so this will give you 100. It means that it is exactly the Cauchy square inequality holding, but this is holding at equality. If this is equality, it means that I must have ui by vi is equal to k. It means ui is 1 by x minus xi, and that divided by 1 is equal to k. It simply means that I can say x minus xi is equal to 1 by k, where I goes from 1 to 100. What is the meaning of this? It means that whatever value or the subscript you give to xi, for each of them that must be equal to 1 by k. It means I can say that x minus x1 is equal to x minus x2 is equal to x minus x3. Means all the factors are equal, because this is going to be, x is a variable, so x1, x2, x3, x4 all are equal. It simply means that there is a contradiction in our all these roots. What the contradiction is? In the question they are saying that all the roots are distinct and real. So of course they are real, but they are coming to be equal. It means this is not the correct thing. Means this is not the correct statement we are begin with. It means this equation has no such distinct, means the equation has no roots. There another case one can think that suppose I take px is equal to 0. In px is equal to 0, then I have the p dash x is also 0. And px and p dash x, if both are 0, the roots will not be distinct. This can only happen if I have some equal roots. So in this way we can prove that this function or this equation has no real roots in both of the ways. The first way was the calculus, and the second way was by theory of equation. Alright, so see you in the next video with some other good question in problems you must try. Till then, stay math active.